Hello, hello, hello.
I haven't talked to you since last year.
That's not true.
Wait,
Well,
well, on the podcast, right?
I guess we haven't talked since last year, like voice to voice.
Yeah,
Just been slacking. Much of the
yeah,
clickety clackety. What's
yeah.
new?
Oh, not a whole lot. You know,
The
just
year.
same old, same old. Yeah, same stuff, different year.
So I think this is it the second week in a row we're not alone?
Yes, it is. Well, I don't remember.
Last 3 out of 4. Yeah, this is the last 3 of 4, including this one will be with a guest.
That's pretty good. We're on a
So I
roll with guests
will I
now.
will let our guest introduce himself.
Hello, I'm the guest. My name's Jason Swett. I'm the host of the Ruby Testing Podcast and big fan of this show.
Good to
Thanks for
have
joining,
you. We've
Jason,
we've both been on your podcast.
You sure have.
separately because he couldn't handle the both of us together.
No, that would be like guest overload. Too good for one show.
No, it would just be me and Chris getting distracted for an hour, which is what happens on this podcast. So
it's entertaining, at least. I hope.
I hope. I don't know. So Jason, I'm gonna say your name as much as I can.
All right.
You mentioned you have the Ruby Testing Podcast. Do you want to tell us a little more about kind of what that is, what you talk about, maybe some guests you've had on?
Yeah, sure. So I'm a Rails developer, have been for a number of years. I started in like 2011 with Rails. And over the last like year or so, I've kind of developed a focus of Rails testing. So mainly helping people who are new to Rails testing get comfortable with Rails testing. So I write all about that stuff at my website, codewithjason.com. And then in addition to like the blog posts and stuff I put out, I do like videos on YouTube, my podcast, and other stuff like that. Teach classes, that kind of stuff.
Awesome.
Cool. What? So we were going to talk with you about doing that for legacy projects. What kind of like projects have you worked on? Like client stuff, or worked at companies on legacy projects, or what kind of things have you been on?
Yeah. So just for a little bit of context, in my career, I've been both an employee and a freelancer at different times. So mostly for like the last 5-6 years, I've been a freelancer. So I've had a chance to work on a lot of projects. And if you would believe it, most of the projects I've worked on have been legacy projects.
So when you say legacy, what are we talking here? Like in terms of Ruby and Rails versions?
Sure. So I find that like most of the characteristics of a legacy project aren't really unique to Rails. They're kind of like the same no matter what technologies you're working with. So, and I'd like to get you guys' take on this too, but like the main characteristic is like everything takes forever. Things that should take minutes take hours, and things that should take hours take days. And there's some things sometimes that you just can't do because the system is in such bad shape. Another issue is that deployments are often scary. There's so much bugginess and that kind of stuff that people are afraid of doing deployments. And so these deployments become like this shuttle launch exercise. It's like, well, we know that every time we deploy, everything catches on fire. So let's only do it once every 3 months or something like that. And then the result of that is because you deploy so infrequently, the deployments are bigger and there's more of a chance for stuff to go wrong. And so more stuff does go wrong and it just gets worse and worse. Another aspect of legacy projects are like the development team is always perceived as being behind. And so you're under pressure to cut corners to meet deadlines and stuff like that. The stakeholders are not like super happy. And the last point I'll mention is that due to all these things, developer turnover tends to be high because like developers are really lucky in the sense that we are really like in high demand. So if you find yourself working somewhere where everything's terrible, you're probably not going to work there very long. And this developer turnover just like exacerbates the whole problem. So legacy projects are kind of a nightmare.
Yeah, I've definitely spent some time on projects like that in the past, especially, consulting. You end up with a lot of that because you get pulled in to help, fix something or whatever that their developers are struggling with or just don't have time for or something. Why do you think things end up in that situation pretty commonly?
Mm-hmm. That's an excellent question. So the frank answer is that just like most programmers are really just like not all that good of programmers. And like to be fair, programming is super hard in the sense that like it's really hard to write an application that is going to be able to be maintained for months and months and years and not just have it like collapse under the weight of its own complexity. That's really difficult. And like I myself, just like everybody, I've written a lot of really bad code. Code that like over time becomes really expensive to maintain. And so I think the reason why so many projects are like that is because like most developers, this is just the way it is, most developers are like below that threshold of having that skill to write code that is clean and understandable enough that you can maintain it over months and years and it stays maintainable.
Yeah. Do you feel like there's these things where we have like weird business requirements that are maybe not clear that kind of end up in the code so that because it's not super clear what you're trying to build, sometimes your code ends up like reflecting that and then you just it kind of works good enough and you leave it and you move on to whatever other thing you need to build. Is that sort of an aspect of what happens?
So I think there's maybe a couple questions in there. So like the first item, are there like weird business requirements that are like that make the code a challenge to write maintainably or something like that? I think most applications that most people write, we're not doing anything super crazy. It's mostly just like CRUD type stuff. And so I don't think that's it. I think the fact is just like it's really challenging to no matter what you're doing, even if you're writing simple stuff, just an application grows over time and there gets to be so much stuff that it's hard to keep it. One big thing is it's hard to keep the repetition out as something grows. When you have like 6 or 8 models, you're fine. Maybe even when you have like 15 models, you're fine. But when you have like 30 to 50 models in your application, repetition that wasn't a problem when you only had a few models becomes really like acutely painful when it grows to a larger size.
Yeah, I definitely have seen that where you end up with something where you're like, okay, it's simple enough for us to just kind of copy paste this because at the same time too, you might be like, well, it worked here, but I didn't write it, so I don't fully understand it, so I'm just going to copy this and then make changes as I need to or something for your similar use case, but not exactly the same. And so
Yeah.
you kind of just copy it instead of maybe reuse the same code and just make it more flexible or something.
Yeah, and I think that approach is actually not a bad approach necessarily, as long as after you do it, you have the discipline to go back and refactor. Because like for me, like when I'm developing any particular feature, I was actually just thinking about this exact thing the other day. I don't have the ability to like see a piece of code and then write a feature that's similar and like refactor it beforehand or as I'm going to make it so that like at the second I'm done, everything is like really DRY and there's no repetition. I find that I have to write it in a repetitive way, and only after I'm done can I like take a step back and say, okay, where is the repetition and how can I factor that out? So I think that approach is fine as long as you come back and refactor after. A lot of the time that refactoring step doesn't happen though.
Mm-hmm.
So this kind of like, this reminds me a lot of a blog post I'm working on because I've been thinking a lot about this like the last few months, and so I agree with everything you said so far. I think that what I think I would add is that sometimes I think at least I know I do, like I get in the zone about working on a feature and I work too quickly. So like I just want to like finish it. And so a lot of times I like defer things like, oh, I'll come back and work on that. I just kind of want to get the feature delivered. But I think a problem is a lot of times we don't circle back to work on those things, right?
Mm-hmm.
Do you agree with that?
Yeah. That, I have that same issue where I'm not super disciplined in general. And so I have to give myself certain like guardrails to make sure that those things happen that require discipline, because I just don't have I have the same thing happen where I get into the zone and I don't want to, like, for example, stop what I'm doing and get out of the zone and like write a test for what I'm doing, because I just want to get to the end of what I'm working on right now. So that's a challenge. Kind of my way of meeting that is I will make a note. I always work off of a to-do list. And so I'll just add to my to-do list, like test for such and such. I actually don't do TDD a lot of the time. I'll work on the feature and I'll make a note to write a test after. And then I make sure that I actually do write the test after. But yeah, I think that happens. The same exact thing you mentioned to me, same exact thing you mentioned happens to me, where I get in the zone and don't want to stop.
Well, I think over time, like that, like compounds, and that is how we end up with like a lot of technical debt. And like testing is a really good example of that. The other thing is like when you were talking about the way you kind of work is like you kind of have to write that duplication, then come back and then take a step back and look where you can kind of clean it up. I think a lot of times like that, not saying you do this, but like the intention is, oh yes, I'm going to do that. And then it's like, hey, we need this thing delivered. It's like, okay. And then you're moved on to something else. So that's just my kind of experience.
No, that's totally the case. And the reason why it's so common for projects to be in bad shape like that is because it's super hard. There's like the really misaligned incentives of, you have one incentive of writing clean, understandable code that's going to be not super costly to maintain in the future. And you have the competing incentive of getting things done on a timeline that seems reasonable to your stakeholders. Those two incentives are totally opposed. And so that's what makes it really hard.
Do you have any tips on helping align that better?
Yeah, one tip is just to like give yourself permission. This has worked for me at least. Give myself permission to do what I need to do to make the code as high quality as it should be. Because like I think a lot of times I have succumbed to the pressure of external stakeholders and said, okay, I need to get this done by 2 days from now because they're expecting it 2 days from now. And so I cut the corners that are necessary to get it done in that short period of time and shove it out the door. And then I move on to the next thing. But nobody was holding a gun to my head making me do that. And what I need to step back and realize is that it's better for the business, including these stakeholders who are pressuring me to go fast. It's better for everybody if I don't cut corners and if I do a reasonably good job. And just like mentally giving myself that permission goes a long way.
So we're kind of talking about like getting into legacy applications. I don't necessarily want to jump the gun, but I do want to ask, like, so what are some of like the first, like you've kind of defined what you consider like telltale signs of a legacy app. What are some of like the first steps you can take to try and remove technical debt, whatever it takes to kind of pull apart those complex layers?
Yeah. So not to get too meta about it, but the first step is you have to like decide what your goals are, and you have to get some level of consensus in the team. So like, let's say you're on a team of 10 developers, and let's say I'm new to the team. If I go in there and I just start like making what I think are improvements, that's not necessarily going to get us to a good place in the long term. Because like, imagine this like code base that is kind of like homogeneously bad. If I go in and start randomly making improvements, then it goes from this like code base that's kind of all the same, and now there's like this one weird corner that I've touched, and I've like imposed my personal style there that's like different from the rest of the team's style. The code might be like more easy to understand in that area that I've touched, but the other developers come across it and they're like, wait, what's this like weird area of the code that looks different from everything else? It's structured in an unfamiliar way, all these things. That's not a good approach. So kind of the 0th step of this endeavor, if you want to turn things around, is you have to get consensus among the team. First of all, is like, does the team even understand that there's a problem? Does everybody agree that the code base needs improvement? Because if not, then you probably can't do anything about it. Like if everybody agrees that it's, acceptable and that's just the way things are, then you can't get everybody to fix this problem they don't think exists. So that's one part of it. But let's say
it creates a lot of tension. Like you're almost wasting time to them.
Yeah. And frankly, if you're working with those kind of people, my reaction is just to go work somewhere else because there's nothing that can be done with those people. But let's say, most of the time in my experience, the team wants things to improve. They recognize that the code is not as good as it could be. And so what I would want to do is just talk with everybody and say, okay, what do we think is bad today? What do we think it would mean for that stuff to be good? What are our goals for improving the code base? And kind of like actually, get everybody together in a meeting and make a list of these things, write that down somewhere, share it with everybody, and kind of come up with a plan for improving those things. So we can talk about like more details inside that, but that's how I would start at a high level.
Cool. Chris, do you have any questions before we kind of move into that?
No, let's dive in.
Okay.
Cool.
And I would love to hear you guys' thoughts on this stuff as we go too, because I know that you guys have worked on legacy projects a bunch too. So feel free to jump in at any point.
Yeah, I don't know that right now I have anything else to add, but I guess I'd just like to hear now, like, so you've identified these things like with the team. Do you have any examples like legacy code you've run into, any examples that you can give where you've started to improve it, how it went, things like that?
Yeah. So my like guidebook that I've used in doing this stuff is the book Working Effectively with Legacy Code by Michael Feathers. And one thing that he says, and I've totally found this to be the case, is that one of the main characteristics of legacy projects is that they're lacking in test coverage. He actually defines in the book, he says, what is legacy code? Legacy code is code without tests. I think that's kind of an interesting definition. I don't know if I'd exactly put it that same way myself, but that book has been really helpful. So given that legacy code usually doesn't have test coverage, there's this kind of chicken egg problem. The code needs to be changed in order to, So let's say I jump into a new legacy project. I'm tasked with making a change. I don't understand the code in the area where I need to make a change. And so I want to put test coverage on it so I can make the change safely. Because I don't want to make a change in an area of code that I don't understand and break something because I don't understand what I'm doing. The problem is, oftentimes in a legacy project, it's impossible to put test coverage on a piece of code because it's structured in such a way that makes the tests impossible. And what I mean by that is there's often like tangled up dependencies. So if I want to test like a certain class, I need to, in order to write a test, I need to spin up some test data and instantiate that class, put that class through whatever exercise it needs to in order to get into a testable state. Like I need to reproduce the conditions for testing that class. And then I need to make my assertion. if there's all kinds of dependencies, if class A depends on classes B and C in order to be instantiated, and classes B and C depend on classes D, E, and F, and whatever, I can't write this test. So this is a big challenge of like, you can't change the code until you understand it, but you can't understand it until you change it.
Wow. Yeah.
Yeah,
So,
I've definitely come across that before. Like, you're like, well, I don't even know where to start because there's 30 if nested if statements. They're all talking to different things, and it would take you days and days and days to even begin to write any sort of test for the existing code as it stands. And then you're like, okay, well, how do I address that?
Yeah. Yeah. Luckily, there's some techniques you can use. So I think like with all the background stuff out of the way, I can finally like start to answer your actual question. So let's say that I have a method that's like, it's a monster of a method. It's like 100 lines long, and it's in this huge class that's like 1,000 lines or something like that. I can't write a test for this class because there's too many dependencies. What I can do is maybe I can take that method, that 100-line method, and I can just cut and paste those 100 lines of that method into a brand new, fresh class. All that class has is that one single 100-line method. But because it doesn't have all the baggage that the big original class has, I can write a test for this class. And maybe I'm not able to take all 100 lines. Maybe it's, even hairier than that. Maybe I can only grab like 10 or 20 lines or something. The point is, I can grab a chunk of that code, move it into a new separate place. And then, since this new class is so small and free of the dependencies that the other one has, I can write tests for that class. And the significant thing is, I haven't changed hardly anything. I've taken those 20 lines, completely unmodified, character for character, they're the same. The only difference is that where those 20 lines used to be, now I'm instantiating this new class I created, and it's just doing all the same stuff. That is a pretty low risk change.
So in those situations, how does it what happens so that pulling it out allows you to set up your case ahead of time so that it's testable in that situation where it wasn't before?
Well, let's just take a really extreme example. If I have, I don't know, let's say you have a user class in a Rails project. A user model is like often where you'll find like, those gigantic classes that do way too much stuff. And I can't instantiate my user model because it needs all kinds of other information in order to really be, I don't know, let's say to create an instance of a user, I need to have like first name, last name, email, address, all these dependent objects, like let's say an account, and then the account needs some other data and stuff like that. It's just really difficult to even instantiate a user.
Are
But
these,
if I take,
are these associated objects, like for the sake of the discussion, are they like active record relationships?
Sure, yeah, let's say they are.
I only ask because like when you're talking about like setting up the world essentially like to run tests, like active record, like the more intertwined I am in these tests, the more hard I realize it is to test. So I'm interested to hear what you have to say now.
Yeah. So again, to like make a really extreme example, let's say the user class, let's say you want to start writing tests for the user class. There's one method in the user class that this is extreme to the point of being silly, but there's a name method. So the name method just takes the first and last name and concatenates them. No, that example sucks. But let's say you just take one line or 5 lines or something out of some method in that user class and put it in, what's something that a user could do that's pretty minimal?
Like confirming an account.
Yeah. Basically, my point is that if you break out this new class, you don't have to instantiate a user anymore. You can just instantiate whatever that new method means. So maybe later in our conversation, I'll be able to come up with like a concrete example that's more helpful. But my point is that if you take the stuff out of the class, then you no longer have to instantiate the class. That's the significant thing.
Gotcha.
So
Because it's like, you know, you now have a class that really is just takes in no arguments or whatever, and so you don't have to set up as much. Whereas this other thing might have totally unrelated dependencies, like maybe you're testing something, but you have to confirm an account before you can use a user, and it's like,
Yeah.
well, this is unrelated to this thing that I want to test. So if we just get rid of that, we get to like focus on the thing I care about.
Yeah, that's exactly it. You did a much better job of describing that than I did.
It reminded me when you were talking about this, one of the approaches that I did on a bunch of legacy projects, like especially anytime there's, you know, 40 conditionals in some giant method, I would go through and pull out every one of the conditionals that I didn't understand, put them in their own method and try and give them a, a description that was whatever they were testing, try and name that, and then go back and replace that conditional with a call to that method so that it would be sort of describing everything as you read through the method. And then that allowed me to like finally understand what the heck was going on there. But the other thing was I could go and test those methods out individually really, really easily at that point.
Yeah. Yeah, and that reminds me of another technique that can aid the understanding of a piece of code that's hard to understand, which is sometimes I'll do this. I'll take a chunk of, let's say, 10 lines of code, and I'll just comment out the whole entire 10 lines. Then I'll look at the first commented line and I'll say, what do I think this does? I'll write an assertion for it. Maybe I have no idea what it does, and so I'll just write, expect blah, blah, blah to equal the number 1 or the string ASDF or something like that. I know that line is not going to give me that value, but I don't know what to expect, so I just put ASDF. I'll run the test, and the answer is 47. And it's like, okay, now I'll change my test to say 47. Then I'll go to the next line, do the same thing, and by the end of it, I will have 10 tests, one for each of those 10 lines of code. Now I know that those 10 lines are completely and thoroughly covered by tests. And then I can feel free to like change variable names, change the structure of the code and stuff like that. And usually what I find is those 10 lines of code that I'll end up with just like 3 lines of code, and it's now abundantly clear what they do.
Mm-hmm. Yeah,
so it's
I feel like you can also tease out some of the, because one of the hardest things with the legacy code is like when a method has side effects that aren't explicit but are clearly important to the program. Those are the hardest to tease out, And so when you're doing that sort of work, you're breaking it down to the point of like, wait, why did we modify this instance variable here? And then you realize, oh, like this is some of the things that were maybe not obvious as you were going through it the first time or the first 10 times even. And then you start to tease those out and realize like, okay, this method's doing like 10 things, even though it says it's doing 1. And those I feel like are probably where all of like anytime you're afraid of changing stuff, if it's not clear what it's doing, it's usually because there's weird side effects that aren't explicitly there. And so maybe when you catch those, you can go refactor them and say, okay, let's make that an official thing that we call as a method or something. And then it becomes obvious.
That's a great point. And that's a case in which you can't do that thing where you like copy 100 lines of a method and move it into its own class. By the way, that's called the sprout class technique.
Okay. And it could be a good one where if you try it and you realize it's not working right after you moved it, then you realize, oh, like this is more entangled than I thought it was.
Yeah, exactly. And so the thing that I do in those cases is like, if there's a 100-line method, I have a desire to break that out into its own class, but I see like on line 30, it starts to modify some instance variable, some kind of global something or other. then I'll say, okay, well, that's like off limits to me right now. Let me take lines 1 through 29 at least, and I'll move that stuff out. And then usually there can be some kind of way, because I think, the reason that stuff is hard to work with is because you're kind of modifying those instance variables are, I guess this is what they refer to as like mutability and immutability. So I like to try to take those things and change it from a value that kind of gets like passed around and modified by whoever, changing it to something that rather than that, you have like, you change it into things that are immutable. So you ask for it once rather than passing around a value that might get changed by whoever and you don't know.
Yeah, or even just giving that piece of code an explicit method that you call that says modify this, and you at least now have a name for it that you can like go and put in wherever you need, and that ends up, I feel like, helping no matter which way you go with that, as long as you can figure out what it's doing whenever you have these side effects. If you can figure out what and why, then you can start to just reorganize it in any way that you want so that it's a lot better in the future. But I always felt like those were the hardest to tease out in legacy projects.
Yeah. I'm trying to think of like a concrete example. The thing that's coming to mind is like, imagine you see a line that's like result equals result dot sort or something like that.
Mm-hmm. Yeah.
Maybe instead of that, you could have 2 separate variables or a separate method, so that instead of modifying the result variable, you just have a different variable or method or something like that.
Yeah, like a lot of times, and you see this all the time, is like a variable gets reused and modified from an array to a hash back to an array and then whatever, and you're like, I don't really understand what's going on here. Like, what am I interacting with? And I mean, that's part of maybe the duck typing in Ruby that we deal with, but at the same time, like if you just change those variable names to be like, sorted results and have a separate results variable, then even more clearly which is which and what it's for and where it's used at.
Yeah, exactly.
So what other refactoring, like you mentioned the Sprout, what was it called? Sprout class?
Sprout class.
Sprout class. What other techniques like that do you use?
Okay, so Sprout class is when you move a chunk of code into its own class. There's a closely related one called Sprout method, which instead of breaking it out into its own class, you just put it into its own method. So maybe taking that 100-line method and splitting it into a 10-line method and a 90-line method for starters.
Gotcha. And I guess that's similar to like what I mentioned with pulling out a conditional you don't understand to its own method and trying to give it a descriptive name for what it's checking.
Yeah.
Effectively the same idea.
Yeah. And just by the way, like some of these refactorings are described in the book Refactoring by Martin Fowler. I just got that book like a couple months ago, and I found out that like, oh, hey, a lot of these things that I do all the time have names. So that book is really useful for that purpose. And
Did you
Sprout class? Mm-hmm.
Did you get the Ruby edition?
No.
Or did you buy the new edition?
I bought the super old edition that was in Java.
So he just released a new version that's in JavaScript, but like in between that, some people put together a version of the book that's written in Ruby.
Cool.
Yeah, that one's on my list. Do you have that one?
I do. I think I bought it. I bought it online somewhere. I'll link it in the show notes. But it's cool because it's like you don't have to go through the extra mental strain. Like if you work in Ruby every day, it's a lot easier than like, oh, I work in Java every day, So.
Yeah, that one has been on my list for a while because I'm curious if it has any stuff that's like specific to Rails applications.
I haven't gone through reading it. I'm the worst. I have. Yeah.
I have so many books on my shelf that I have not so much as cracked open.
It's always like, oh yeah, I can't wait to do this, and then it comes in. I'm like, oh, I'm too busy to read. So sorry. Continue.
No, that's exactly how it goes, I think, for every developer. Yeah, so Chris had asked, what are some other legacy project techniques? Sprout class, Sprout method. I didn't mention the name characterization testing earlier, but that's the name for like when you write tests for code that is as of yet untested, and you're just kind of doing like exploratory assertions, just kind of poking at it to see like, does this equal 1? Oh no, it equals hello. Okay, I'll change that to hello. That's what Michael Feathers calls characterization testing from that same book I mentioned. I call it reverse TDD because it's like it's too late to TDD it now that the code already exists, but I can comment out all the code and then write the test first and uncomment the code after. So it's the same exact like benefits of, well, not same exact benefits of TDD, but very similar in value to TDD. But of course, you're doing it after the fact.
That's
Another
cool.
thing,
I like that.
Because I was actually going to call it the exact same thing, but I was like, no, that'll be dumb. But now that you say it, I'm like, heck yeah, reverse TDD.
So another thing that I like to do, this is also from the Michael Feathers book, is so I'll start with a clean working state in Git, and I'll take a class that is like, the class that I want to improve, and I'll just start messing with it. I'll start like wildly renaming variable names. I'll move code around and stuff like that. And then when I'm done with it, I'll just revert all my changes. And that's really valuable because it's like, it's super freeing to say, I'm not going to worry about like if I break stuff, because I'm not even going to like try to keep this. I'm just going to make a bunch of changes. And I find that often, like after I rename a bunch of variables and change the structure and stuff like that, I understand what the code does. And then I can, again, I'll blow it completely away and I'll start over writing tests this time. And I can do my real refactoring a lot faster, having done that kind of scratch refactoring.
Yeah, that's certainly something that I do even in regular projects. Like anytime you have something, you're like, man, I haven't. This definitely needs to get cleaned up. And if you just experiment with a few ideas that you have on how it could be better, then you can blow it away and like just kind of quickly test out, is this going to work? Maybe, maybe not. Is it promising? And then you can just go and actually do it if you realize, yeah, that might be a good approach, because you might also just as equally find out that's not going to work, and then you're back to where you were. So I think that's a really good option. One question I was going to ask was, do you start testing at a high level, or do you start testing at a low level when you get into these projects?
Usually low level, I think. So I think a good approach is to start with whatever is easy. So a big challenge to, let's say you go into a project that has no tests at all. Now you have two challenges. One is like the structure of the code is not very conducive to testing. Another is that the testing infrastructure is non-existent. So you can't just write your first test. You have to put all this infrastructure in place before you can. So if I'm in a situation like that, I'm not going to write a test for something that's like in any way challenging. I'm going to try to find the closest thing to like 1 + 1 = 2 and write a test for that, because my test will be trivial and it'll add like almost no value at all. But the value in that exercise will be that it'll force me to build some like minimal test structure in order to support that first test. And then after that point, everything incrementally becomes easier. So that's like, when I first come into a project, I'll look for that kind of like wedge to get my foot in the door with testing it and make all the other tests a little easier.
Mm-hmm. Yeah, that makes sense. Because you're effectively trying to do this as well to learn the project, most likely, because it's new to you. And if the whole test suite is non-existent, then it's good to just start simple and go from there.
Yeah. And not to go back to like all the soft skills and stuff, but like it really is like, if we're talking about like the reality of making these things actually happen, that's a huge part of it. Like I worked somewhere where they didn't have any test coverage on any of their JavaScript. And so there was a rule imposed. Everything we write needs to have a test now. but we didn't have like a testing strategy. And so it wasn't really possible to just write tests from now on because we hadn't decided like how that would be as a team. So that's another step that you kind of have to get in place before you can start.
Yeah. That reminded me too. Go ahead.
That's one of the that's a rule like we put in place when I worked at my previous job because we had a pretty legacy app like to the T. Is that like, you know, we're trying to move away from it, but if you're working on it, if you add stuff, obviously like test it, and we kind of had testing strategies. But also if you touch a piece of code that's not tested, it's your responsibility to test it. And so that way, like you slowly, like you're not hitting pause on production stuff to like write tests and refactor, but you are getting to like build your test suite as you go. And I thought that was really valuable.
Yeah.
Along those lines, I was going to mention one of the things I did when I inherit projects from clients or whatever was anytime that their error tracking or whatever would come in and let me know there's some bug, I would go and write tests for those to reproduce those, and that also helped build up the test suite a little bit faster because you're like, I'm going to fix this regardless. I might as well just write a test for it to reproduce it and then have the test, from here on out as well.
Yeah. Yeah. And that's a case where it takes like, I feel it takes like extra discipline to write the test for that. Because I find when I find a bug, I want to fix it and get it done and deploy it as quickly as possible. And often writing the test for the bug fix will take like 2 seconds, and then writing the test will take way longer. So, my point in saying that is if you, dear listener, find yourself having a hard time writing tests for that kind of stuff, you're not alone. It just really is super hard to do.
Yeah. And I feel like that's where, you just have to have some sort of process you stick with to just, all right, we're going to do this. It's going to suck and it's going to be hard, but eventually it will get better. And once you have a lot of those, or even just a handful, it starts to be like, okay, well, now we know how to set up these tests, or we can refactor it so that these tests are going to be a lot simpler and our code will be simpler too. And those help kind of point out like, okay, this is kind of really hard for us to test, which probably means it's coupled too well to various things. So if we refactor this and test it, then we kind of get wins from both of those.
Yeah. Yeah. And it's like, it's something that takes time to like build up those muscles. It's kind of like, I'm not going to like go from my current like unhealthy diet to starting tomorrow. I'm only going to eat lettuce forever because that'll probably stick for like half a day.
Oh, shoot. Really?
If I cut out like, I'm not going to drink pop anymore starting tomorrow. And then I'll like slowly cut out. I know, you guys, pop.
Oh, I was like, what? It sounded, I thought crack for some reason.
Crack.
Wow. I mean, that you could do that too.
Say pop. I'm just like, what? I don't know. What is that? I guess I thought of Pop Rocks.
Oh yeah.
Yeah. I really
it's
need
what
to
we call the fizzy drinks up here. In some regions they call it Coke. It's like, you want a Coke? What kind of Coke do you want? Mountain Dew?
Yeah. It's like you go somewhere, I'll have a Coke. What does that mean? What do you mean?
Yeah, what kind of Coke?
Hey, Jason, remember every time we come to visit you and we order a Coke, they're like, is RC Cola okay? And we're always like, what is going on here? Where are we?
Wait, that's something you experienced? Because I know you've been up here to Michigan, right?
When we were in Nashville several times, I think. We got presented with the RC Cola question, and we were like, what?
We went to that random restaurant with Andrew, and
it happened multiple times. We were somewhere else, and same thing happened, and we were like, this is strange. Where are we?
I forgot all about that.
So anyways,
sorry,
back off that tangent.
Oh, it's fine. I saw this Onion article that said they were going to rename the Mason-Dixon line to the Waffle House IHOP line.
That's hilarious.
Yeah, it's really bizarre when you go to different regions and like it's all different chains and stuff. It's really disorienting.
Yeah, and it's very different. Like I went out to New York City for a year and was like, oh yeah, a lot of the staples that we have here in the Midwest are not a thing here, or they have like one location or something. Whereas, there's Dunkin' Donuts everywhere there, and we don't really have a whole lot of them. They're starting to grow here, but it's definitely interesting to see those pockets of restaurants and foods and whatever else.
Yeah.
What were we even talking about?
I
It
don't
was
know.
Ruby or something.
As a podcast, both host and guest, I don't particularly value staying on topic. So
Right. Me neither.
yeah,
Well, so while we've shifted off,
I think we were talking about computers.
something
if that
like
helps.
that. We're at 45 minutes, and before we go, I wanted to make sure that we had time to kind of talk about what you're working on in like the testing world. So, like, you have a mini course, and you're putting out lots of blog content. So, kind of want to hear like where that came about and like how you're trying to help people with testing. I'm just really curious to hear all that.
Oh yeah, sure. So the thing that's on the top of my mind right now is in 3 days or 4 days or something from the time of this recording, I'm headed to India to speak at RubyConf India. So that'll be pretty interesting. So if you happen to be in India in late January, swing by the conference. But yeah, that's going to be great. I'm going to be talking about legacy projects in Rails and how to use tests to kind of get a handle on those legacy projects. So that's something I've been doing. But basically, like, I'm trying to produce as much stuff as I can to help people who are new to testing get comfortable with it. So the biggest thing I'm working on right now, I announced this on my podcast too, is I'm working on a book called Rails Testing for Beginners. I expect that will be available in its first version, at least in sometime early 2019, like spring or so of 2019.
Awesome.
That's awesome.
Yeah.
Congrats on that.
Yeah, thanks. I have like 29 pages done so far. So
That's actually a lot.
Are you testing your writing?
Nope. So yeah, that'll be great. I'm just shooting for 50 pages for the initial version, just so I can get it out there.
Are you self-publishing?
I'm self-publishing. What I want to do, the approach I want to take is I'm going to self-publish it and like prove the idea, then take it to a publisher and be like, hey, check out this book that is already selling and people clearly want because they're buying it, and then get them to take it up under their name. I don't know if that's going to work, but that's what I'm going to try.
That's cool.
Yeah. So there's that. Every week, I haven't done it in a little bit because of the holidays, but every Tuesday at 2 p.m. Eastern, I do a free Rails testing workshop. So that's basically me on a video call. We get on a Google Hangout and we just do some coding together. So that's pretty fun. People seem to enjoy it. I have a what I call my free Ruby testing micro course, and you can just get that for free. And that's, hence the name micro. It's really small. It's like a 4 video thing. So I try to put out a good amount of like free helpful stuff.
That's awesome. Yeah, I see you a lot on the interwebs now, and I'm happy to see that.
Yeah, and I've been seeing you too. You had a post on the top of the Ruby subreddit the other day.
Yeah, that one took off a lot more than I thought it would.
Yeah, that was pretty cool.
Basically, like, spent the last year kind of like twiddling my thumbs, being like, oh, should I keep writing Ruby? And then I just was like, yeah, I should. And so I wrote about it. And the coolest part of that was like I was sitting on the couch and talking to my wife, and I just stopped talking to her, and she's like, what's wrong? And I was like, Matt's just tweeted it out. And like I just stopped talking.
I didn't even know that.
Awesome.
Yeah, it was cool. It was like surreal to see your name like on there. So
yeah, that's crazy. That's awesome.
So where can the people find you on the internet?
You can find me at codewithjason.com. That's a good starting point. I try to make it so if you land there, you can find everything else pretty
It's a
easily.
cool domain name too.
Yeah, it could have worked for you if you had beaten me to it. So I'm glad I got it first.
No, I rock that last name. It's so unique.
Yeah. So there's that, and you're listening to this podcast, so probably you're into podcasts. You can go to the Ruby Testing Podcast in iTunes or however you get your podcasts. I'm taking as of this recording, I'm taking a little break. I'm doing it kind of like seasonally, but I'll be starting that back up in probably spring of 2019.
Awesome. One thing I want to mention, excuse me, before we go, this isn't like an ad or anything, but I have a job posting that I'll mention, and that is for a company called Lens Rentals, LENS rentals.com. They are looking for Ruby devs, and it is remote, and I worked there for 4 years, and I can attest to how great the company is, as well as the cool projects you get to work on. So if you're interested in that, send your resume to jobs@lensrentals.com. Once again, that's not a real ad like I got paid for, but they're looking for folks, and I want to help them out because even though I don't work there, I still like them. So, Chris, you got anything else?
I don't think so.
You know what we haven't been doing the last 2 weeks?
What's that?
Our updates.
Oh yeah, we
But
haven't.
Now's probably not a good time either. So let's start next week with that.
Okay, yeah,
I
let's
think-
do that.
Well, this is tantalizing because now I personally want to hear your updates, but I don't get to.
Oh,
I'll have to wait
sorry.
until the next episode, I guess.
Right.
Yeah.
Well, it's
We
a great
can-
cliffhanger. It'll keep people, listening to the show.
We have another guest next week. And then the next week, we're going to have to, like, if we don't have a guest, we're going to have to, like, figure out what to talk about like we did when we first started doing this thing.
We'll figure it out. We're seasoned pros now.
all 22 episodes. Awesome. Well, all right, everyone. Have a good week, and we'll talk soon.